So now we're going to go through how to use differentiation to find the coordinates of a turning point or stationary point. So there's two ways of calling the same thing. So let's imagine we have a curve, and let's continue maybe with the same one that we had in the previous video. This is like a continuation of that video. We have, so f of x equals x squared plus 5x plus 6. Okay. So we have -2, -3, and then this is 0, 6, right? Now, we could probably use completing the square. We can use completing the square to find out what this turning point is. But I want you to just kind of think of what the concept is. So we know that coming down here, we have a negative gradient, right? Because it's going down. So it's negative, it's negative, it's negative, and then it switches and it becomes positive. So at some point here, where this is negative, 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 the gradient is 0 before it becomes then positive. So hopefully that makes sense. At that one point, we don't see it obviously as a flat line, but at one point, the gradient is 0. Okay, so let's kind of run with that for a second and think that dy over dx for this particular equation, like we said in the other video, was 2x plus 5, and that's just quickly saying that dy over dx is n times x to the power of n minus 1. If we're just using the kind of quick formula and not, you know, differentiating by first principle. So this is our gradient function. So to find the equation of this one stationary point, obviously if we had a cubic, it would be 2. If we had like a quartic, it would be 3. But what we need to do is we need to make this gradient equal to 0. So we solve this as we would for like a linear expression. And we get that x is equal to minus 5 over 2, or minus 2.5. To find the coordinates now, all we need to do is plug this value into this original expression to find the y value at that particular point. We're not going to plug it in here because we're just going to get 0, because we know that the derivative at this particular point is 0. So let's plug it back into that particular point. So it's a bit of a nasty one. Minus 2.5 squared plus 5. So minus 2.5 plus 6. So you can use a calculator for this. Oh, my calculator has just died. Right, so minus 2.5 squared plus 5 lots of minus 2.5 plus 6. We get minus 0.25, I think. So minus 2.5 minus 0.25. And that broadly looks like it's correct, right? It's between minus 2, minus 3, and somewhere down here. So I hope that made sense. And let's just maybe go through another example of like a cubic before we end the video. Because maths is all just about getting that practice in. So if we have f of x, I'm not going to sketch it out this time, is equal to, let me just make something up, 5x squared plus 7x plus 8. Okay, it's going to probably be pretty nasty. But dy over dx is going to equal 3x squared plus 10x plus 7. So then if we make that equal to 0, again, just solving it like an equation. This is probably a very bad example because I don't think there are factors for this one. Oh no, there are. But remember, when we have a quadratic equation, we make it equal to 0, we have to find our factors. So you're probably not going to get one that's a quartic, because then you'd have to solve it via a polynomial method, but I can go through that in a later video. Anyway, but here we're finding factors that add up to 10 and multiply to get 7. So yeah, we're probably not going to get factors here unless we use the quadratic formula, but let's maybe do that anyway. So x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Oh my gosh, this calculator It's so dead. Or another kind of shortcut method is to just plug it into a calculator as a function. And just kind of see where it hits 0. So it is -1 is 1. -1 is 1. But let's just do it properly maybe. So it's going to be x equal -10 plus or minus the square root of 10 squared minus 4 times 3 times 7 over 6. So the first value is going to be -10 plus the square root of 10 squared minus 4 times 3 times 7 over 6. So it's going to equal -1. That's x1, and x2 is going to equal -10 minus the square root of 10 squared minus 4 times 3 times 7 over 6. So you get something that's like -7 over 3. And then if we plug these into our original equation, you get -1 cubed plus 5 lots of -1 squared plus 7 lots of -1 plus 8. You get -1, 5. And then let's just plug in the second one. You get some really nasty number of like 167 over 27. It's not going to be a proper question that you get, but yeah, it was just to show you an example of how you would do it with a cubic. You would just differentiate it, get a quadratic, make it equal to 0. But hopefully that made sense. It's the concept that at one point, let's say we had these two are the stationary points. They're the point where the gradient is going to be equal to 0. Thank you so much.